Okay, let's dive into this. In a perfect world, your IP address is kind of like a digital passport stamp. It says exactly where you're from. But what happens when that stamp gets covered up, or worse, completely forged? Today we're going to trace traffic back to its real origin, even when it's trying to hide.
So, picture this. You're running a popular website. You check your logs to see who's visiting. But wait a minute. Every single person seems to be coming from the exact same IP address. It's like you're throwing a huge party, but the doorman announces every single guest is, well, himself. This happens all the time when your server is sitting behind something like a proxy or a load balancer.
Right, so what exactly is this doorman? It's a proxy server. It's an intermediary that sits between your users and your web server, forwarding all the requests. Now, this is usually a good thing. It's great for security, it can speed things up, but it creates a massive blind spot. Your server only ever sees the proxy's IP, which makes it incredibly difficult to spot abusive behavior or even just understand where your users are coming from. To fix this, way back when, the developers of the Squid proxy server came up with a really clever, really simple idea. They decided to pass along a special note with every request. This note, an HTTP header called X-forwarded4, or just XFF for short, quickly became the go-to, de facto standard for keeping track of the original visitor's IP address.
The job of the XFF header is super straightforward. It's basically that special note we just talked about, and its only purpose is to carry the original client's IP address along the entire chain of requests. So as a request hops from one server to the next, this header makes sure that crucial piece of information, where this whole thing started, doesn't get lost in the shuffle.
Okay, so how does this actually work in practice? Let's break it down. Think of it like you're forwarding a package. The very first entry in the header is the original sender's address. This is our client's IP. The request starts its journey right here, with just this one IP in the header.
Now that request hits the first proxy server. What does the proxy do? It looks at where the request just came from, and it appends that IP address to the end of the XSF list. So as you can see, the list is starting to grow.
And yep, the process just repeats itself. If that request gets passed through a second proxy, that one does the same thing. It adds the IP of the server that sent it the request. So you end up with this chain where the leftmost IP is always the original client, and the list just gets longer as it travels. Seems simple and elegant, right? Well, mostly.
And here is where our simple solution gets complicated. The Mozilla Developer Network, a super reliable source, gives us this very stark warning. This helpful little header has a critical flaw, one that can open up some major security holes if you're not paying attention.
So what is this big risk they're talking about? It's actually shockingly simple. Because XFF is just an HTTP header, a malicious user can create their own X-forwarded4 header before they even send the request. They can stick any fake IP addresses they want right at the beginning of the list, effectively lying about where they came from.
This is where you have to learn how to separate fact from fiction. You have to think about this header in two distinct parts. The IP addresses on the left, the ones supplied by the client or any other proxy outside your network, are totally untrustworthy. You just can't believe them. But the IPs on the right, the ones added by the proxies you control inside your own infrastructure, those are trustworthy. The real trick is knowing where the untrusted part ends and the trusted part begins.
This leads us to the most critical question of all. If you're using this header for something important, like rate limiting to stop denial of service attacks, or maybe granting access based on a user's country, which IP can you actually trust? Because if you trust a forged IP, a bad actor could bypass your security completely.
So, the good news is, there is a safe way to read this header. The key is to completely flip how you look at it. You don't start at the beginning of the list, with the untrusted data. No, you start at the end, with the servers you know and control. You have to work backward from what you trust. This brings us to the cardinal rule for using the XFF header safely. To find the real user IP, you have to read the list from right to left. You skip over all the IP addresses that you know belong to your own trusted proxies. The very first IP address you come across that is not on your trusted list, that's the one. That's the most reliable IP you've got. It's the address of the first external machine that sent the request into your system. Okay, so for anyone out there actually running a web server, this is a huge takeaway. Just logging the XFF header by itself isn't enough. You should always log two things. One, the full, complete X-forwarded4 header string, and two, the actual source IP of the request that hit your server, which will be the IP of your last proxy. Together, those two pieces of information give you the complete story of that request's journey.
Now, it's worth mentioning that the tech world did try to standardize all of this. There's an official successor to XFF called the forwarded header. It's more structured, it can hold more info, but honestly, in the real world today, the original X-forwarded 4 is still way more common, so understanding its quirks is absolutely essential.
And that really brings us full circle, doesn't it? The X-forwarded 4 header leaves this trail of digital footprints all over your server logs. And the real challenge, the most important lesson here, isn't just about being able to read them. It's about knowing which ones to trust. It's a perfect reminder that in the world of web security, you have to question and verify absolutely everything.